Yes, students. Hi, students. Once again, welcome back to Diksha Vedantu English channel. This is Suhas, your chemistry master teacher. Students, most of the students ask this one, right? Students, sir, please teach the periodic classification of element foundation class, right? Students, this is a demanding lecture. Today, I come with entire periodic classification of element units, my dear students. Students, before starting the class, let me know in chat section. The PPT is clearly visible and the voice is clearly audible. If it's audible and visible, then let me know in chat section, everybody. Let me know. Yes, students, you already know, right? Vedantu learning centers. Vedantu learning centers now near you. For example, in Delhi is there, Patiala, in Karnataka mein, Bangalore mein, Tamil Nadu, Chennai, Coimbatore, and all time in all location Vedantu learning centers is there. Please join it. Students, come on, let's start with periodic classification. We already know, right? In class 9th, we have learned that matter around us is present in the form of elements, right, my dear students? In unit 3 and unit 4, what we learn, students, the matter is there now. They are what? Pure or made up of by elements. Compounds and mixtures of the elements contains atoms of only one type. What they told here, every compound are made up of only one type, right, my dear students? Do you know how many elements are till date? How many is there? Now we have totally 118. Oh my god, 118 elements are there in our nature, and also in out of this 118, only 98 are naturally occurring. What they told here, totally 118 is there, sir, but 98 elements are there now. Those only naturally occurring is nothing. Another 20 elements is there now. They are man-made or synthetically prepared elements. Okay, totally how many elements are there in our periodic table, students? Totally 118. This unit is very important, students. Before starting the class, I told here one important thing. Students, I need your support. Please share the channel and please subscribe the channel. If you not share the channel, then definitely we are not taking classes in this channel no more. Okay, we have only 1 month time. Please share the channel as much as possible. Okay, as different elements were being discovered, scientists gathered more and more information about the property of these elements. What happened? First, one periodic law or anything is come. What happened after founding new elements? The scientists gather their all property of the elements and they make an one table. This table is called periodic table. What they call, students? Periodic table. Looking for some pattern in their property on the basis of which they could study such a large number of elements with ease. Why this concept is come? This periodic classification elements or periodic table concept is come because, students, for some time we need to do some experiment. We need to do some experiment, or we need to do some reactions. What happened? Sometimes we need relevant. What? We need relevant elements. For that, instead of searching the elements, if we make in one column and put all elements in respective properties, then we can easily pick those elements by using their related property, right, my dear students? This is very important. Okay, after this, first let's start with making order out of choice. Early attempts at the classification of elements. First, who come first to attempt the periodic classification of elements or periodic table? First ever scientist, Doberner is there now. He is a first scientist, come early and he is the first scientist come first to attain about classification of periodic table. What he do? Related to classification of periodic table. Students, the voice is clearly audible. Please check it once, students. My dear students, please check it once. Yes, we have been learning how various things or living beings can be classified on the basis of their property. We already know, right? Even in other situations, we come across instantaneous of organization based on some properties. For example, in a soaps are kept together at one place. Oh my god. Yes. In a shop, what happened? One place soap, one in one column entire soap we place it, and in another one column or in another one table or in another. Whenever we enter mall, what happened? Soaps are kept in one side. Similarly, other detergents are kept in one side. Bathing soaps are kept in another step. Other thing, right, students? Similarly, scientists made several attempts to classify elements according to their property. Oh my God! Not only one scientist attempted this, students, many scientists come, many scientists attempt the same thing. What happened? For example, you were Suhas sir taking chemistry and other teachers also taking chemistry, and we are all gather one at a time and we make a one plan. Oh, come on, let's attend this, let's attend this. They do like this. Okay, the earliest attempt to classify the elements result in grouping the then known elements as metals and non-metals. In earlier, what they classify? All metal to only metal and non-metal. In earlier, they do simple things, students. Only they classify metals in two categories. One category is metals, another category is non-metals. Now, and after that, after gaining some knowledge, after gaining some chemical property, they classified all metals and all other non-metals, all elements in some categories. Let's start with first one. Dobirner Tates. He is a first scientist who come first and attend the first attempt to which one? Periodic classification or periodic table in the year 1817. Oh my God! I think before 207 year before. 207 year before, what he do? He do that attempt. John Wolfgang Dobirner, a German chemist. Who is this fellow? Who is he? He is a German chemist. Try to arrange the elements with similar property into group. What he do? Take some elements and try to arrange these in one group. The elements have same property. He do something. What he do? He takes some elements and arrange the elements according to their properties. Okay. He identifies some groups having 3 elements each. So he called these groups as triads. He identifies some groups. He identifies elements with 3 members. These 3 have same property. This 3-member group he called as what? Triads. Very important question, students. Triad. This is a basic. What is triad? The arrangement of elements in groups. The arrangement of 3 elements in one group. It is called triad. Okay. I hope it's clear, my dear students. Any doubts? Okay. After that, Dobirner showed that when 3 elements in a triad were written in the order of increasing atomic mass. Oh my God. What did he show? He arranged the 3 element in increasing order. For example, here look here. Nitrogen, phosphorus, arsenic, right? 14, 31, 74. Then the atomic mass of the middle element was roughly the average of the atomic mass of other 2 elements. He give one clarification, students here, Dobirner. He arranged the elements. He arranged the group of 3 elements in one group. Or he arranged one group of 3 elements and he called these elements as it. Triads, and these elements how we arrange in the increasing order of their atomic masses. And also he told one important things here. He told one important point. What he told, the middle term, exactly middle term is there na. It is the average of, he told like that, the middle term or middle term atomic mass, it is roughly average of first one and third one. Very simple, students. If we add both first one and third one atomic mass, and if we divide these 2 atomic masses by 2, or if we take mean of these 2 values, then we get the atomic mass of middle element. He get the atomic mass of middle element. Okay. For example, take the triad consisting lithium, sodium and potassium. The respective atomic masses are 6.9, 23 and 39. What is the average of atomic mass of lithium and potassium? How does this compare with atomic mass of Na? Very simple. Here, let's take another 3 elements. 6.9, 3.9. Let's take average, students. 39 plus 6 is nothing but 45. 45, 46. Let's assume 46. Approximately we get 23, right? That's why. Similarly, take that one. As sodium, he can arrange the sodium metal in exactly midpoint. First lithium, sodium, then potassium. These 3 are the triads. Not a triads, it's a triads. Okay. Given below table 5.1 are some groups, 3 elements. These elements are arranged downwards in order of increasing atomic mass. Can you find out which of these group form Dobirner? Very simple. Here, chlorine, bromine, iodine. It easily form, right? It form a 35 point take average we can form. Here it is 14 to 74 average is around, you will find group B and C Dobiner traits. Yes, it is not arranging this one and this one. Both are Dobiner traits. Dobiner could identify only traits from the elements known at the time. On before, at 1817, only we know few elements. At this time, he only arranged those elements in traits. But after time, sometime what happened? Hi Munawar. Hi. Sorry, Munwar. Hi Munwar. How are you? How are you, my dear students? How are you, Munawar? 1 second, students. Hello? Sorry for that, my dear students. Students, what I told here? First, Dobiner traits. In your CBC class 10, this unit completely, this chapter they removed completely. That's why this is very important. That's why this video I mainly dedicate to my entire golden batch students. This is very important. Please concentrate here. First attempt is Dobiner attempts. It is called Dobiner traits. He simply do this, students. He take three elements having same property. He arrange it in the increasing order. How he arrange it? I told once again. I repeat once again. Arrange it in the increasing order. And exactly middle term is there now. This middle term atomic mass, it has average atomic mass of first one and third one. This about Dobiner traits. Okay, but this Dobiner traits get fails. It's not be useful. Why? Because he only arranged these traits up to some elements only. But these traits get failed. Who is this Dobiner? Dobiner studied as pharmacist as Munzenberg in Germany and then studied chemistry at, oh my gosh, Strasbourg. Eventually, he became a professor of chemistry. He is also professor of chemistry and pharmacy at the University of Jena. Dobiner made the first observation on platinum as a catalyst and discovered similar traits of elements which led to the development of periodic table. Oh my god. Students, we know, right? Whenever we want to build one apartment or anything or any house, the foundation is very important. Similarly, this Dobiner plays a very important role to discover in the place of discovering periodic table or anything. He is the first scientist who come first and attempt some periodic classification. He attempt the first periodic classification of elements, and he make one idea about classification. Right, my dear students? Then Dobiner get fails. Why? Because he arrange only 3 to 4 traits. He can't arrange this trait as more elements. That's why it get fails. Next one of the second one, Newland law of octaves. Now, Dobiner done now. Next, new scientist is come. The attempt of Dobiner encourage other chemists to correlate the property of elements. Oh my god. It is important, students. This line is very important. What happening here? Dobiner do some attempt. After Dobiner, other scientists is there now. They look Dobiner. Oh my god, he do some attempt. Then come on, they also make one scientist group, and they also attempt, and they come with new idea and make a periodic table as a classification. They make periodic another classification, another attempt. Second scientist what is the second attempt of periodic table? Newland is a second scientist who come first and attempt law of factors. Newland attempt the second law, right? Second attempt. It is also called Newland law of octaves. Very simple. In 1866, this Newland, an English scientist, arranged the known elements in order of increasing atomic mass. He also take idea from Dobiner. He also arranging in increasing atomic mass. He also do same thing. Dobiner also do same thing. He also arrange periodic classification of elements in increasing atomic masses in 3 elements. So he make a group of 3 elements, but he take atomic mass idea and he arrange everything. He started with the element having the lowest atomic mass, hydrogen, and ended with thorium, which was the 56th element. On the time, only 56 elements are known. On that time, on 1866, we know only 56 elements. Okay, my dear students, he found that every 8th element had properties similar to that of first. What he found that? He found one important property here. Every first element is there now except hydrogen. It is have same property of its 8th element. He compared this to the law of octave found in music. Therefore, he called it law of octaves. Why? this law or this attempt or Newland's periodic classification of elements called law of octaves, because first element have similar property to the eighth to their eighth element, right? First one have similar property of their eighth element. That's why he compared this entire classification as law of octaves is nothing but music. Sa re ga ma pa da ni sa, right, my dear students? That's why it is known as Newland law of octaves. In Newland octaves, the property of lithium and sodium were found to be the same. In Newland first octaves, what happened? Sodium and lithium property both are same. Sa, second one re, ga, ma, pa, da, ni, sa. Sa is same as sa. Right, my dear students? This thing is confirmed. Sodium is the eighth element after lithium. Similarly, beryllium and magnesium resemble each other. Similarly, second element. After lithium, beryllium is coming. Beryllium and magnesium have same property. But he do one thing here, students. He arrange entire element in the increase of their atomic masses. Okay. What's happened? Yes, here there. This is example. Lithium has sodium, beryllium, magnesium, sodium, potassium. This thing is happened. 8. Okay. It was found that here, are you familiar with musical notes? Oh my god, here one important is there. Come on, let's look here. In the Indian system of music, there are 7 musical notes. Yes, we know that. Sari, Gama, Pa, Da, Ni, Sa, Sir. Right, my dear students? In that West, there are notation. In the Do, Re, Mi, Fa, Su, La, Ti. Oh my god, I am weak at music. Okay. The notes is a scalar separated by on and off step frequency intervals. It is not important. That about some basic idea about Indian music. That's all. Students, come on, let's move. It was found that law of octaves was applicable only up to calcium. Now we are come to limitation. Why this law get failed? Why? Up to calcium. Up to where is calcium here, my dear students? Up to calcium only it carries. After calcium, every 8th element did not possess properties. After calcium, 8th element is there na, did not possess their property. What they do, what it happened, they did not possess their property. Very simple. Okay, my dear students. Next point, it was assumed by Newlands that only 56 elements existed in nature. What he assumed? At the time, only 56 elements are occurring. He assumed that, only 56 elements are present in nature. There is no new element were discovered. They discovered in future. But what happened? After later, several new elements also discovered whose property did not fit into the law of octaves. What happened? Its property is there now. It did not fit. That's why it fails. Second limitation. Third limitation, my dear students. In order to fit elements into its table, Newland adjusted 2 elements into the same slot. Oh my god, here look here. Cobalt and nickel is there now. To fit the elements to the Newland law of octaves, he placed 2 elements in same group. It's not happened, right? We can't place 2 elements in same group, right? If we made a classification, then we need to put the elements in different groups. Right, my dear students? This is also third limitation. Can you find example of this? Yes, we get cobalt and nickel and everything. Thus, Newland law of octaves worked well with lighter elements only. From using these 3 properties or by using these 3 points, we can easily conclude that Newland law of octaves only worked till lighter elements only. That is nothing but till calcium only. Okay, students, this is about Newland law of octaves. Thus, Newland law of octaves, yes, is done right. Here some question is there. Come on, let's solve it. First one, did dominant traits also exist in the columns of Newland octaves? Compare and find out. Anything is there? Yes, lithium, sodium, potassium is there na? It is also there. Yes sir, it is there. The example is lithium, sodium and potassium. Then, what were the limitation? The Newland law of octaves is only applicable for lighter elements. First, what is this, students? Only it is applicable for lighter elements only. Right, my dear students? What were the limitation? Yes, both are done. Doberer, it only applicable. We have only few traits, but we don't have long traits, or we don't have so many traits. That's why limitation we already done. Right. Now next one of the next one, making order out of choice. Mendeleev's periodic table. Now we come to the third scientist who attempt the periodic table. Who is the next one? Mendeleev. Come on, let's discuss here. Who is this? Mendeleev. Mendeleev was born in Tobolsk in Western Siberia. Russia. Oh my god. He is a Russian scientist on 8 February 1834. After his early education, Mendeleev could join a university only due to the effort of his mother. Dedicating his investigation to his mother, he wrote some book. She instructed with example, corrected with love, and traveled with me to places spending her last resource and strength. She knew that with the aid of science, without violence, with love but firmness, all superstitions and truth and errors can be removed. Oh my god. Just look. Just look how many lines is there? Around 6 lines. 6 lines. Long title. Okay, students, this about Mendeleev. Come, let's discuss Mendeleev's law. When Mendeleev started his work, how much elements were known on the time? Only 63. Now 118. Just imagine, students. New scientist come. He invited new element and he gave some idea. Then we need to fit this element to n periodic table. Come, let's discuss main thing here. This is Mendeleev periodic table. Before entering to that, Mendeleev concentrated on the compounds formed by elements with oxygen and hydrogen. He do simple here. He does not go with that atomic mass and any other things. Examine the relation between atomic mass of the elements and their physical and chemical property. What he do? He don't only concentrate on that atomic mass. Instead of that, he compare that atomic mass with their physical and chemical property. It is nothing but he mainly concentrate on chemical property and forming of a compound. He do one thing. He take entire elements and he arrange the forming of compound by using oxygen and hydrogen. We already know, right, students? In metals and non-metals also we discuss. The metals almost they occur as a oxide, otherwise any hydride metals, right, my dear students? It's nothing but we can easily identify by using this. He make it the formula of the hydrates and oxide formed by an element were treated as one of the basic property of an element. He make one basic property. What he do? He treat element with oxygen and it forms some compound with some formula. He take that formula and he arrange all elements depends upon this formula. For example, some elements form MO, metal oxide, MO only form. Instead of some element form M2O3, some elements different forms, right? M2O3, M3O5, and depends upon that he place the all elements with similar property and pinned the card together. You know what? He do one thing here, students. He then took 63 cards. Oh my god. What the idea is? G. Very simple. He takes 63 cards, my dear students. Just look here. Here one book is there. He split this book. He takes 63 cards and he write its formula and he place it in a wall. Place it what he do in a wall. He observed that most of the elements got a place in a periodic table and were arranged in the order of their increasing atomic mass. What he know that one? What he conclude that one? Whenever he place that what paper strips or cards in the table na, it is also look like arranging. It is also there in the order of arranging their atomic mass. Okay, my dear students. It was also observed that there occurs a periodic recurrence of elements with similar physical and chemical property. On the basis, Mendeleev formed a periodic law. Who is the father? Who is the father of modern periodic table? This one is only. Mendeleev is the father. Okay. Mendeleev periodic table contains vertical columns called group, horizontal row called periods. Going 416 mark, can I get 620 days? Yes, you can. You can mark. Aim doctor, you can. You can get. Don't worry, you can get. Please follow our channel. Definitely you can get. You can. Don't worry, students. Tomorrow onwards I starting NEET classes. Okay, in this channel I starting NEET classes. Entire organic your Wasser is teaching. Don't worry, follow me. Definitely you can score marks. This unit is also there in your class 11. It is also very important. Please focus here. What is group, students? Groups is nothing but vertical columns. This one I show that in picture. Look here. These are periods. These are periods. Period number 1, 2, 3, 4, 5, 6. From left to right. These are called group. By using first group, whenever we react these elements with these metals, then it forms R2O and RH molecular formula. Okay, like this. Titanium, this thing is happened. Here, let's discuss their achievements. What this achieve? What it gives some idea? Yes, when developing the periodic table, there are few instances where Mendeleev had to place an element with a slightly greater atomic mass before an element. Oh my god. Where is that one? Yes, here, there. Where is that one? Search, students, in that. He placed element some element. It is low in atomic mass, but he placed it one in that group. Where is that? Where is that? Student, search here, please. (90 to 95) no. Yes, welcome. Aim doctor, definitely you aim doctor, right? You definitely you become doctor. Don't worry. Something is there. Okay, he do that one because their similar property could be grouped together. For example, cobalt. Oh my god, we already searched it, right? Cobalt, that one. Where that cobalt is there? Calcium. Yes, here, look here. 58.93, 58.71. Oh my god. Look here. What areas G? Oh my god. Appeared before nickel. Looking at table, can you find out one more such anomaly? Can we find out that one? Here, there, students. I already searched it. No, 190, 190. No, nothing here. Also not there. 196, 200. No. Look here. Lithium, beryllium, 14, 15, 18, 22, 24, 29. Look here. Aluminium and silicon. Aluminium atomic mass is 29.8 and 28.09. It's nothing but it tells very clearly, students, we need to arrange the elements not on the basis of atomic mass. We need to arrange their basis on physical property and chemical property. Then we can easily make a periodic table. Okay. Further, Mendeleev left some gaps in his periodic table. Instead of looking upon these gases as defect, Mendeleev boldly predicted the extinction of some elements. Oh my god. What he predict? He thinks something. What he predict? Definitely in future we can. Thus, other scientists came and they discover more elements. Mendeleev named them by prefixing Sanskrit numeral eka to the name preceding element by the same group. Some element what happened, my dear students? It has same property of the same element. It discovered later after arranging Mendeleev periodic table. He discovered later what happened. He make some space for those elements and he told that this is eka. Eka means it has same property. Okay, understood? Then similar to eka boron, eka aluminium is there. Look here. This is eka aluminium. These are the masses. This provides convenience evidence for both correctness and usefulness of Mendeleev's periodic table. This is one of the best achievement. And also further, it was the extraordinary success of Mendeleev's prediction that led chemists not only to accept his periodic table but also recognize him. Due to this, they are not only accept this. They are recognize him by using this periodic table. Oh my god, what a man, right? Noble gas like helium, neon and argon have been mentioned in many contexts before is. These gas were discovered very late because they are very inert. What happened? Noble gas is there now. They are very inert. They have very low boiling point. They are exist at very low temperature. That's why these gases discovered after some long time. That's why these gases are placed in different group. Very simple. This is also one of the best achievement. But you know one thing, students, Mendeleev's classification, Mendeleev's periodic table also get failed. Why? Because come on, let's discuss. Electronic configuration of hydrogen resembles that as alkali metals. Like alkali metals, hydrogen combines with halogens, oxygen and sulfur to form compounds. Similar formula as shown in the example. On other hand, just like halogens, hydrogen also exists as diatomic molecule and it combines with metals and non-metals to form covalent compounds. Very simple, students. He never gives specific place for hydrogen. Why? Because this hydrogen acts as a alkali also. It shows electronic configuration. It only have one valence electron in its valence shell. Then other alkali metal first group elements also have same thing. But what happened? It also forms covalent bond with metals and non-metals. Ionic bond, right? Certainly no fixed position. That's why it is a first ever limitation. He never give place or he never predict the place of hydrogen in a Mendeleev table. This is a first limitation. Okay. Then thus isotopes, all elements pose challenge of Mendeleev's periodic law. Another problem. He can't predict the isotopes. For example, isotopes, what are isotopes? It have same atomic number but different atomic mass. Due to that, he can't predict that one. This is also one of the limitation. Here some questions are there. Come on, let's discuss here. Use Mendel's periodic tab, predict the formula. K2O3, we can predict that. These are the homework questions, students. Please comment these answer in chat section. Potassium, calcium, aluminum, silicon, barium. Please tell it. Please tell it in chat section. Beside gallium, which other elements? Eka boron. That thing is formed now. What was creating his periodic table by using their physical property. He compared those atomic masses. He makes some. He takes some cards. He write its physical property and chemical property. He posted in wall. Okay, my dear students. This is about Mendel's law. Next, move on to the modern periodic table. Oh my god, I told one wrong statement here. Who is the father of modern periodic table? This Henry Moseley. In 1913, showed that atomic number of element is more fundamental property than its atomic mass. Oh my god, he come with new idea. What he do? Up to still, the scientists believe that atomic mass is a basic property. Chemical property and physical property is completely depending upon atomic mass. But Moseley in 1913, Henry Moseley in 1913, he decided one that. He showed that one thing, atomic number is important rather than atomic mass. It's nothing but atomic number is a basic property, not a atomic mass. He described this one and he arranged this element or arrange the elements according to their increasing order of their atomic number. This is very important. What he do? He take property also periodic function of their atomic number. Let us recall that atomic number gives the number of proton in the nucleus of atom. What is atomic number? Yes, we know. Sir, atomic number is nothing but the total number of proton present in in atom. It is called atomic number. Right, my dear students? Any doubts? Students, let me know in chat section. Any doubts is there? Fast, everybody. Fast by everyone. Any doubts, my dear students? Okay, students, let's take 5 minutes break. I am back now. Yes, students. Yes, can we continue now? Next, move on to the mostly term. Sorry for the students, due to some important some personal issues, I can't. Yes, super.
Right.
Yes, everybody, come on, look here. Look here, look here, look here. Okay, next, come on, let's move for this one. This is a modern periodic table. Okay, done. Then let's discuss. 1 second. Yes, position of elements in the modern periodic table. We already know. Mostly come he arrange the periodic table. He arrange the elements in periodic table as increasing order of their atomic number, not the atomic mass. Atomic mass, my dear students. Okay. Then after that, the modern periodic table has 18 vertical column as group, 7 horizontal row. In modern periodic table, totally they have 18 groups and 7 columns. Sorry, 18 columns, 7 groups. Okay, 7 horizontal groups as known as periods. So it's nothing but 7 periods, 18 groups. 18 groups, 7 periods. Okay, you will find all the elements contain the same number of valence electrons. Similarly, you will find the elements present in any one group. How we arrange? The elements have same atomic number. Atomic number is nothing but same valence electron. He arranged in one group. Depends upon the what? Depends upon what, my dear students? Depends upon number of electrons. The same number of electrons. For example, elements fluorine and chlorine belong to group 17. Fluorine and chlorine belong to group 17. How many electrons do fluorine, chlorine have in their outermost? 7 is there, right? Fluorine also 7. This one is also 7. That's why he arranged those elements in group 17. They kept those elements in one group. Okay, my dear students, I hope it's clear. Then here one activity is there. After this one, we have only few questions. This is end of the session. It is very easy unit, students. Here, if you look this compound present in the second period, write down their electronic configuration. Electronic configuration same only, students. What you will find, these elements do have the same number of valence electron along a group. He conclude very simple points. Don't instead of reading these lines, I give clarification here. Students, what he told? Very simple. He told in group is nothing but vertical things. Vertical or horizontal? Groups is nothing but horizontal, man. No. Yes, vertical, sir. Yes, sir. You told only correct. Vertical things is there are vertical groups. They have same valence electron, not same valence shell. But the horizontal one period, in those they have same what? Same valence electron, same valence shells. It's nothing but if in second period it have 2 shells. Sodium, for example, look here. Sodium, magnesium, these all elements have 3 shells in its valence shell. Right? That's the thing. Potassium, everything is same. Okay. Then he gives some example. Arranging 2, 8 to 18. We already know outermost shell. Right, students? Next, more on the trends in modern periodic table. Depends upon valency size. How it varies. As you know, the valency of an element determined by the number of valence electron present in the outermost shell of an atom. How valence is determined? By using their number of elements, by counting the number of elements in their outermost valence shell. How do you calculate the valency? Very easy, students. If the valency electron of the number of valence electron is greater than 4, then we need to subtract those elements by 8 number. Very simple. And atomic size. The term atomic size refers to the radius of an atom. Atomic size is nothing but radius. The atomic size may be visualized as the distance between the center of the nucleus and outermost cell. How it visualized? It is a distance between center of atom and one second. Yes, my dear students. Hi sir, my term exams from May 2nd week, sir. Oh my god, Hema. Okay, your term exams from May 2nd week, Okay. I already done real number, students. Let's start. Let's concentrate. Class 10 entire syllabus. I do that. Don't worry, I do that. Okay, Hema, I need help from you, sir. Hema. You know one thing. If this channel is not crossing 10k, then definitely the channel gets stopped. Okay, this is a new news. Please share the channel as much as possible. We need your support, students. Now we need your support. In 1 month we need to cross this channel minimum 10k students. I need your support. You give supports. Hema, you give support. Please subscribe the channel. Please share the channel. From your side, I need minimum 1000 students from your side, Hema. Please, ma. Please share channel for entire your classmates. Do them. Told them to subscribe the channel today only. Let's plan, students. Let's grow together. Okay. We need your support now. Please share the channel. Okay, students. Then atomic size. What happened? Isolated the atomic radius. We already know. Along a period, what happened? Along a period, the atomic size becomes same, but down the group the atomic size increases. You will see that atomic radius decreases in moving from left to right along a period. From left to right, atomic size is it decreases. Yes, Emma, we need your support. Now we need your support, students. Please share the channel. Yes, ma. Yes, ma. You will try your best, ma. We need support. We need support. Please share the channel. Okay. Yes. Don't worry, students. We are always there with you guys. Okay. Yes, my dear students. Yes, ma. Thank you. Then what happened? You will say that increase down the group. What happened? Atomic size increases from down the group. It is decreases from left to the period. Very simple. Metallic, non-metallic character done. Then trends is done. This about trends. Electron is decreasing because of the outermost. Yes, definitely they can be lost easily. Hence metallic character decreases across a period and increases down a group. Metallic character, what happened? Down a group it increases, but along a period it decreases. Okay, my dear students. Then here some questions is there. How could modern periodic table remove various anomalies? Yes, it gives some space to hydrogen, everything named to S, students. Here, come on, let's discuss your question. Exercise the following. Okay, this thing is completed. Yes, students, I give quick summarization about today's session. Here, in today's session, we discuss anti-Doppler nitrides. Yes, Doppler nitride done, sir. Next. Yes, yeah. Don't worry, Emma. Don't worry. Please share the channel. That's all. We are there with you. Don't worry, student. Don't worry. We are there with you. Okay. Don't worry, Emma. We are always there with you, but we need your support. That's all. We need your support. That's all. I simply do some prank here, Emma. Don't think so much. But we need support, Emma. That's all. We need your support, students. Please share the channel for your friends and subscribe them. Okay, sir. Told to subscribe to the channel. That's all. Okay, Emma. I hope you doing that. Yes, students. Okay, students. Then this about today's session. Any doubts here? Any doubts? Today, Doppler nitride is done. Mendeleev's periodic table and mostly new modern periodic table and Mendeleev's law, Newland law of octaves, everything we done, right, my dear students? If you have any doubt, then let me know. Let me know in chat section, everybody. Yes, anything else, my dear students? If you want this PPT, then I share in my Telegram channel. Please join the Telegram channel. It is there in link. Okay. Yes, students. Yes, whenever you click this link here, VLC is there here. Yes, from using this you can join. 104 is there. You can join, students. Okay. Any doubts, my dear students? I hope everybody is safe and everybody enjoy this session. Please share the channel. Please share the channel, my dear students. I hope you guys are sharing the channel. Emma, I hope on you. Please share the channel. Okay. Please share, everybody. Okay, students. This is Suhas. Ending with a beautiful smile. Don't think too much. Okay. We are always there with you. Thank you so much for watching the video till end. And bye bye. Take care.